The point D lies on L1, where lambda is 2. The line L2 passes through D and is parallel to AB. Find a vector equation of line L2 with parameter mu. The diagram shows a symmetrical trapezium ABCD with angle DAB equal to angle ABC. The point C lies on L2. The length of AD is equal to the length of BC. Find the coordinates of C. So let's have a little look at this question then. What I've done is I've put all the information from section A into the question itself. Here's L1, that line there. I think we may well need L2 as well, which I'll also glean. L2, which I think we need to find. Yeah, we need to find in this section now, here. So we'll need L2. A has these coordinates, B has these coordinates. So D is on L1, that's fine, this is L1, where lambda is 2. So let's work out the coordinates of D then. L2 passes through D and is parallel to AB. Find a vector equation of L2 with parameter mu. Okay, so let's get D first then. So part B, break it down step by step. So D, the coordinates of D, lambda equals 2 at D. So we have the coordinates 3, 2, put 2 in here, 2 2s are 4, 3 plus 2 is 7. Then minus 2, put 2 in here, minus 2, and another minus 2 is minus 4. And then 4, 2 lots of 3 is 6, 4 plus 6 is 10. So there's the coordinates of D, which I'll put in the diagram as well. So there's D. Find the vector equation of L2. So here's L2. We know it's parallel to AB, don't we? Because we're told that. So this line is parallel to this line. We know the directional vector AB, so we can now write L2. So L2 then as a line, R is equal to the coordinates of D. We'll start here, 7i minus 4j plus 10k, plus we're using parameter mu, and then we want a directional vector along here which is parallel, which is the same as this directional vector, 3i plus 2j minus k. There we go, there's our line L2. So we've got L2 now. Diagram shows trapezium ABCD where angle this is equal to the angle of this. C lies on L2 as we said. Find the coordinates of C. So we need to find these coordinates. Now there's symmetry. These two sides are the same. So this distance will equal this distance. We know where we are here. We know this distance and we know this line here. So where does this line satisfy the distance from this to this here, this vector equaling a certain value? So that's the sort of gist of it then, isn't it? So what should we do first then? Yeah, let's get this distance here then. We need this piece of information. From here to here, we need the modulus of AD. So part 2, the modulus of AD will equal, well, it will be the modulus of A to D will be D minus A. 7 minus 3 is 4i. D minus 4 minus minus 2 is minus 4 plus 2, which is minus 2j. And then 10 minus 4 is 6k. So the modulus of this will be 36 plus 4 is 40 plus 16 is square root 56. So that length there is root 56. So this length here is root 56. Okay, so if we have coordinate of C2 then, we know it's on line L2 at C. We'll let mu equal to a parameter value P. Then the coordinates, C has coordinates. What are the coordinates of C? Well, it lies on this line here, where mu equals P. We'll get 3P plus 7. Is the x coordinate. Then we'll get 2p minus 4. and then we'll also get minus p, 10 minus p, 10 minus p, and that's the coordinates of the point C as far as the information from line L2 is concerned. Now we know the difference between this coordinate, the distance from this to this, is root 56. So if we do BC then, modulus of BC squared will be just the x difference squared, the y difference squared, and the z difference squared. So we got 3p plus 7 minus 6 is 3p plus 1 squared, plus 2p minus 4 minus 0 is just 2p minus 4, that squared, and then the z component, 10 minus p minus 3 is 7 minus p squared, is equal to this squared, this squared, this squared must equal the length of the side squared, which is 56, isn't it? Square of root 56 squared is 56, so we've got 9p squared. Expanding the brackets now, 6p plus 1. Next one is 4p squared, minus 8 is minus 16p, plus 16, plus 49 here, minus 2 sevenths is 14p, plus p squared, all equals 56. Okay, so we need to solve for p, and then we can work out the coordinate of c. So 9p squared plus 4 is 13, plus 1 is 14p squared. That's the p squared. 6p minus 16 is minus 10p, minus 24p. And then we've got 1 plus 16 is 17. 17 plus 49, 50 plus 16 is 66. Move the 56 over. 66 minus 56 is just plus 10, isn't it? Equals 0. Okay, we can divide by 2. That gives 7p squared minus 12p plus 5 equals 0. Yeah, 7 and 5, 7p, and then p, and then 1 and 5 will give 12 if we do a minus and a minus. So p will equal 1, or p will equal 5/7. So these are our two possible values for p when it's root 56. Now what's interesting here is this thing could also be symmetrical in the sense that it could also be here, couldn't it? So you've got two possible, that's why you've got two possible solutions. So the smaller one of the two along the line for the value p should give the value, shouldn't it, here by intuition. So just using the intuition, 5/7 is the smaller. So p is 5/7, p equals 5/7 gives, and now I'm going to go back up because I've run out of room here and put 5/7 in here. So it's 5/7, 5/7 here, and 5/7. So I'm sorry about this, but I'm just going to write the coordinates in here. Calculator, 3 times 5/7 is 15/7. So 15 divided by 7 plus 7. So I don't make a mistake, I've just put it in the calculator. 64/7 is the first one. Then 2p is 10/7. So we've got 10 divided by 7 minus 4. Minus 18/7. And then the last one is 50/7. 10 minus 5/7. 70 minus 5/7. 65. 65/7. So there's the coordinates of C then at long last. And again, apologies for the room. I ran out of room on this particular sheet. So I put the value up here for the p 5/7 value.